This is the Systemic DNS Vulnerabilities and Risk Management Panel with a discussion of our esteemed experts. And I will turn over to our moderator, Rod.
Thank you. Thank you very much. Am I live here? Can I go live? Live? Okay, now. Can you hear me back there? No? Okay, excuse me. Let's do a switcheroo. Thank you. Oh, there we go. This one's live. Great. Excellent. Well, welcome to the DNS Vulnerability Panel. We're thrilled to have all of you join us today. This DNS Security and Vulnerability is a collaborative effort. So we're really fortunate to have some excellent panelists today with a lot of experience, and I'll introduce them going down the line here. I'll start with, to my left, Mr. Dr. Whitfield Diffie. Whit is a globally recognized leader in cryptography, encryption, and network security. It's often considered to be one of the fathers of public key cryptography. He's had a long and distinguished career. He was a VP fellow and Chief Security Officer at Sun Microsystems, and was also manager of secure systems and researcher at Northern Telecom. And I now have the honor of working with Whit at ICANN, where he is the Vice President of Information Assurance and Cryptography. To Whit's right is Ken Silva, and Ken Silva is also very well known to many of you, is the Senior Vice President and Chief Technology Officer at VeriSign. Ken oversees their mission-critical internet infrastructure. His responsibilities include oversight of the technical and network security for millions of web addresses in .com and .net. He was previously VeriSign's first Chief Security Officer and Vice President of Technology Strategy. He joined VeriSign with more than 20 years of experience in the telecommunications and security industries. Here directly to my left is Mark Weatherford, who until recently was the Chief Security Officer for the state of California. He is now, very recently, I think within the last couple of weeks, now the Vice President, 5 days into the job, Chief Security Officer at NERC, which is the North American Electric and Reliability Corporation, a very important group for the security of our grid. He's got tremendous experience in both the public and private sector historically. He was also Chief Information Security Officer for the state of Colorado and worked with the state legislature there to pass laws establishing the state's first security program. So he's been on the founding level. I'm Rod Beckstrom, CEO of ICANN, by the way, the Internet Corporation for assigned names and numbers, and will be joining in the panel. To my right, really doesn't need introduction to most people, but we'll put it down for the record, and that is Dan Kaminsky, Chief Scientist at Recursion Ventures. Dan has been a leading voice in computer security community for over a decade. Formerly of Cisco, Avaya, and IOActive, Dan spent 3 years consulting on site at Microsoft, auditing the core designs of Windows Vista, Windows Server 2008, and Windows 7. Dan is best known for his work in 2008 when he found and mitigated a critical flaw in the domain name system and announced that here at Black Hat 2 years ago. A very historic milestone marker. That mitigation remains the largest synchronized security fix in internet history. And then to Dan's right is another great in the field of DNS security and technology, and that's Sandy Wilburn, Vice President for Engineering at Nominum. Sandy is the VP at Nominum, which is a provider to DNS for over 150 million broadband subscribers worldwide. Sandy leads the engineering team at Nominum for all DNS and DNS-related services. In 2008, he was part of the global team that responded to the Kaminsky DNS vulnerability. Prior to Nominum, Sandy was VP in engineering at Determina Software. So we thank all of you on the panel for being here today. And I thought we would start off with having Whit Diffie paint a sort of high-level picture of what he sees as some of the security and stability issues with the global domain name system. So if we can pass the mic down.
My drink and my mic at the same time. Over a fairly substantial length of career in this subject, people have constantly been asking me, well, why hasn't keying infrastructure taken off yet? What's wrong with PKI? And, when people ask you a question like that, you make some excuses. And I ask it a lot of times, and I thought of a lot of different excuses. And the one I particularly like for a long time, and I think it's true, is that it's a capital development problem. You get the benefit comes kind of down rear, and the costs are up front. So it's a bit hard to get it started. And after you get a certain amount of it, then everybody's going to begin to want it. So I was, look, all these people predicting we're going to see the knee of the exponential any time now. But I've come to realize there's another problem, and that is that all authentication, and it's keying infrastructures basically make introductions. The fact you encrypt with the keys once you get them and so forth is subordinate to the fact the essential thing they do is hand you something and say, here, I introduce you to so-and-so, or such and such, or something like that. And so all authentication is relative to some kind of namespace. And one of the problems I realized is people were trying to sell, classic marketing problem, you're trying to sell two things, and you have to sell the customer on both of them. And one was a namespace, and the other was the authentication mechanism for the namespace. And it was not that there was no success. I mean, SSL, for example, finessed this problem very, very elegantly, and it's been probably the most widely deployed crypto security mechanism ever seen. But now, with DNSSEC, it seems to me we may have jumped a major hurdle, because we had a namespace that was already accepted. That had been developing for 20 or 25 years. And now we're merely introducing an authentication mechanism that runs within that namespace. And that now gives us something that will be deployed for its primary use, and once you have authenticated DNS identities, then you'll be able to press that farther and do more with it. So with that, I think I'll yield the balance of my 5 minutes.
Thanks, Whit. 10 years ago, when I left a public sector job to go to a little company called Network Solutions, I thought, man, I got the easiest job in the world. It's DNS. How hard can that be? It's just some domain names, and don't you just use VI to edit them and call it a day? At that time, we were doing, we were doing about high-end speed, about 60,000 queries a second. Now we do over 1 million queries a second. But I've had the opportunity over the last 10 years to see over the last 10 years sort of how DNS itself has changed. Although the protocol has been largely unchanged, its usage has changed a lot. 10 years ago was a pretty big deal when ad networks were sort of using the domain name system to serve up different ads by just simply cycling through different domain names or different IP addresses from those domain names. And that turned out to be a pretty successful venture for them. But then other people got the idea that, hey, we could use DNS to do global site load balancing. We can use DNS to do a lot of things. So what we've seen is an increase sort of in the capacity that has been needed for the domain name system, not just because the number of users grows on the internet or the number of domain names grows on the internet, but because those users and those domains are doing so much more than they did before. So from a sort of a challenge perspective is you have a capacity growth issue where it's redoubling about every 16 to 18 months, where that's an interesting scalability challenge that you have to stay in front of, because if the DNS system doesn't work, then the internet doesn't work. It's pretty much that simple. But then coupled with that, so many users now are getting a lot of bandwidth from broadband. I mean, the definition of broadband used to be a lot lower than what people are actually using today. In fact, most cell phones can actually transmit speeds higher than what the US government, for example, originally classified as broadband. Those devices now become either an attack element or a query element for legitimate purposes, but either way, the growth in malicious traffic or attack traffic on the DNS infrastructure has outpaced that of the legitimate traffic. Now, that's not unexpected, and I think you'd find that in many of the industries. But the challenge that it presents is that you have to stay so far ahead of it because you don't have the time to go around and update 100 or more sites at a moment's notice and throw more capacity at the problem. So it has to be something that's sort of forecasted well in advance. And DNS itself, up until now, really had no security associated with it. It used the UDP protocol, which was a completely stateless protocol, so addresses could easily be forged, and there was no validation that it was coming from any particular place, and so DNS was often used as a reflector attack against other victims, where you could send a relatively small query, and the answer coming from the name servers would be relatively large, so you could amplify an attack 8, 10, or even 64 times what it originally was. So DNS is both a victim and sort of an enabler, if you will, of other denial of service types attacks. So a lot of the research is going on in this space is not just around how to secure the message itself, which DNSSEC does a very good job of, but also how to fortify the protocol itself in the longer term, and thinking sort of years down the road, what is that protocol going to look like so that it's less susceptible to the kinds of attacks that it is today. And with that, I think I'll turn the balance of my time over to the distinguished gentleman from California.
And that would be the one to my right, Sandy.
Hi. So I guess one of the things I wanted to say is, since we've got the panel here, is congratulations on signing the root, Rod and Whit. So that's a very important milestone for the security of DNS. But it's just the first step. There are large numbers of deployment issues, I think, with DNSSEC, and it's an enormously important thing to do, but I think Whit actually said it pretty well, which is there's a large upfront cost in order to get there. And so I think there's kind of two things in key vulnerabilities beyond what they were saying. Is one, how can we get the hacker community to actually contribute to figuring out where there might be additional, DNSSEC has a long gestation period, but how can we get the hacker community to work with us before, I think, what was it, maybe Jeff said something like this at the keynote. Oftentimes it's like 15, 20 years before we find some of the vulnerabilities in things, right? I mean, Dan's vulnerability in the DNS was there the whole time, right? But we didn't know about it. And then we found a solution, a short-term solution, and then people are getting a little bit complacent again, I would say, perhaps. And so we really need the hacker community to come out in force to help us find any additional vulnerabilities in the protocol as we try to put it out there. So.
Thank you, Sandy. And I'm going to do a little bit of a bridge between some of the concepts laid down as a foundation here and the next two speakers. And that is, I feel really fortunate to be here today because, like Dan, I was here in 2008. And in 2008, I had the honor to do the kickoff keynote when I was serving as the director of the National Cybersecurity Center. And the key message that I delivered at that time was the importance of enhancing the internet protocols for greater security. That the best thing we could do to secure the internet was to invest in the fundamental protocols and developing the standards and deploying them, and that without doing that, we could spend many billions, hundreds of billions, or even trillions of dollars on security with a limited impact. And to be here today, to have the honor to serve ICANN and to serve the community, and to see DNSSEC that so many of you have been working on for up to 20 years rolling out, makes me feel truly, truly fortunate. And when we look in that, at what's been accomplished, the first thing I want to do is just recognize the work of the Internet Engineering Task Force. And the IETF has worked on this problem for a long, long time. Many engineers have worked to develop the standards, develop test beds, work through the RFCs. It's been an enormous mountain of work that the rest of us can benefit from. And so we're all very grateful for that. So what happened? So, now the root's been signed. So what does that mean? Does that mean the internet's now safe? No. What it means is that it now can become much safer. but what has to happen for it to become much safer? And there's really two major things that need to happen, or two categories of things. Number one is to propagate the DNSSEC signings throughout the top-level domains of the internet. So as of today, there's a number 9 that I believe have been signed with the new DNSSEC root key. That's 9 out of roughly 270. So there's another 261 to go. So the namespace has to be secured in that fashion. Then there has to be the development of the applications to leverage this, whether it's the browsers or it's the email systems or any of the other systems that are leveraging the domain name system need to be evolved. And then, of course, as well, the ISPs need to adopt and support the name server capabilities in supporting DNSSEC. So now we move into a new phase which really relates to adoption, and I think it's very relevant then that I now hand it over to Dan Kaminsky, who's been working in this area, and then we'll cap off with Mark Weatherford, who has been very involved in deploying DNSSEC in the state of California.
So I'd like to begin by actually joining Rod in his congratulations of the IETF. There are a tremendous number of engineers who have literally put maybe up to even decades of their life into the project of DNSSEC. I was not one of them. I was, in fact, like many engineers who thought DNSSEC was too much work for not enough benefit. You know what? I was wrong, and that's okay. Being wrong just means the world's more interesting than than you thought it was. DNSSEC turns out to be one of the most interesting technologies that I have ever seen in my career. Not simply for its ability to fix problems in DNS itself, although it does a pretty comprehensive job of that, but in actually providing a infrastructure, a operating environment in which some of the single most pernicious problems in all of security cannot merely be addressed, but addressed efficiently, effectively, affordably. These are words we don't generally consider in security. We usually just think, oh, well, we're just going to demand it, we'll mandate it, we'll require it. No, it doesn't work like that. It's got to be good. It's got to be operational. It's got to work in the field. And the really interesting thing, about 18 months ago, I sat down and said, okay, all my friends keep telling me I got to look at this DNSSEC stuff. I'm going to write a server. I didn't tell anyone. I just sat down and wrote one. About 18 months ago, I completely changed my tune on DNSSEC. Why? Because the server was really good. So all the things that I've been saying for the last 18 months about securing email, about securing the web, about making it possible to authenticate across organizational boundaries, you know what? I think all of y'all should be a little sick of it by now, because it's been a lot of talk and not a lot of code. And so I'm going to tell you all right now, in about 5 hours, we're going to be releasing a lot of code, and we're going to show you just how much value this technology is going to bring to securing the internet.
That sounds very tempting for us all to attend that session, that's for sure. Mark.
So that means everybody write it down. You need to come to Dan's presentation this afternoon. This is going to be another event just like 2008.
Not another like that.
Well, as Rod said, I am formerly the CISO from the state of California. So I am not an official representative from the state of California any longer, but I'm going to talk about it a little bit today. Unless you were in state government in October of 2007, the date probably doesn't mean a lot to you. But if you're in California state government, the date would mean a whole lot, because that was the day, that was the month that OMB took ca.gov offline. And I can tell you that gets your attention. Fortunately, I wasn't in California. I was the CISO in Colorado at the time, and I remember reading about it and thinking, holy cow, somebody is in big trouble. What happened was there was California has almost 2,000 .ca.gov domains, ca.gov and state.ca.us. And they're scattered, they're not only within state government, but a lot of local governments, fire departments, libraries, all over the place. And they're managed by the state, and at the time, perhaps not too well managed. And there was a domain in a county that had some malicious code on their website, and OMB had been trying for several months to get them to fix it, and they didn't fix it, so OMB just took ca.gov offline. So I remember reading about it when I took the job in California. I thought, you know what, I'm going to fix DNS. That's going to be one of the things I want to work on, one of my big projects. And I said, you know, DNSSEC is the way I want to do it. If we're going to fix DNS, let's really fix DNS. So I started rooting around trying to find some money, and I got a Homeland Security grant for it last year to implement DNSSEC in the state. And so the challenges, and I am not a DNSSEC expert, but I do understand what Dan just said, that DNSSEC will fix a lot of our problems. I want citizens in the state of California, when they go visit a DMV website or a Department of Healthcare Services website, that they're sure that they're visiting that website. DNSSEC will do that for us. So they're in the middle of, actually in the beginning phases of a deployment right now. And it's been a challenge. It is, one, I had to convince everybody up through the governor's office that this was the right thing to do, because this is a huge cultural change, and it impacts a lot of people and a lot of organizations. So that's kind of where I'm focused on this, is the organizational change required to do something like a DNS implementation on a large government organization.
It's great. Well, I want to thank all the panelists, and now we'd like to open it up to questions from the audience for any of the panelists or any number of the panelists. And while you all think of those questions, I'll ask a question to the panel, and anyone can pick it up they'd like. And that is, so if each of you had a magic wand and you could pick the next thing that needs to get done for DNSSEC to get deployed successfully in whatever is the environment you most care about or deal with, what do you want to get done? What do you want to see happen?
Well, I think the first step in getting DNSSEC out there is basically making it just dead simple for people who are today's DNS administrators to sign zones. The tools for that have been woefully inadequate. Just, 25-page documents about all the different steps that you have to go through to sign zones. Recently, the plug is, my plug is we produce something that makes it somewhat easier. And I think other people are doing the same kinds of things, but I think it's super important, and that's probably the first step to getting more people to sign their zones sooner.
Great. Any other panelists want to take a stab for that? While someone from the audience, we have a question from the audience. Please go ahead.
Yeah, sorry, the rhetorical dumb question, and I know VeriSign's on the panel. Wouldn't it have just been easier just to mandate for high security, high important websites, just to everyone have EVSSL? A lot easier, a lot simpler, and that way you actually know, and you could verify, and you just click on that left little button on your browser and see who it is that you're talking to, and that's it. A lot easier than adding in this extra crypto and extra work at the multiple levels.
Well, it is kind of interesting because you use the term, couldn't you just mandate that they use EVSSL? I don't know that any mandate has ever actually worked on the internet successfully, easily. Certainly, EVSSL is a rapidly expanding implementation of SSL, but even with the extended validation SSL certificates, there still was not a firm mechanism in place to prevent cache poisoning and those sorts of things. So even even if you could validate that the site and know that you were going to the site, not everyone was actually paying attention to all of those indicators. For instance, there's always been a padlock at the bottom of the browser, and even before some of the domain validated SSL certificates from some CAs were viewed as somewhat risky or riskier than EV SSL, people still didn't pay attention to the padlock at the bottom, and they still don't pay attention necessarily to the green bar. It's a good technology, but it takes a while to get 1.8 or so billion users kind of accustomed to that. The other thing is that they also relied on the user having to make a decision. What DNSSEC does is it takes that decision making sort of out of their hands, and it all happens in the background, and the infrastructure itself does that validation for them. And I think that's one of the key things that DNSSEC does differently than most of the traditional PKI systems, and that is it doesn't require the user to have to do a whole lot. It requires the real smart IT staff in the background to do a lot. And what we hope will happen is that the browsers and the other client applications which exist on the desktops will then begin to recognize those messages and present them to the user in a way that actually makes some sense to them and tells them when it doesn't validate why that happened.
Yeah, I have I guess this is a simple question. I remember when Dan came out with his disclosure about the weaknesses in the DNS, we were sitting around the office kind of trying to come up with solutions of how we could fix it. And one of the solutions was, why don't we just just have the DNS server send 2 replies instead of 1? And then somebody came up with the realization that that's physically impossible because the DNS servers are now almost running at capacity. So when I heard about, okay, we're going to start implementing DNSSEC, I thought, wow, if we don't have the capacity to run, to do something that simple, how do we have the capacity to actually run DNSSEC?
All right, so what you refer to is actually, we called it multi-query. So it was actually really interesting because when we're sitting at this meeting at Microsoft, and there's like 16 of us, and we're going over all the possible solutions that aren't just doing what Dan Bernstein said to do in 1999. And the problem with multi-query, capacity is an issue, but the thing is, theoretically, you could just do multi-query in situations where there might be an attack. The real issue with multi-query is there's no guarantee from request to request that you'll get the same answer back. Like, if you look at Facebook, or you look at Hulu, or you look at a lot of very, very popular sites, you can't just say, well, we'll secure the entire internet but Hulu, because that doesn't fly. So multi-query was dropped not because of capacity, because we were able to scope when the capacity had happened. It was dropped for compatibility reasons.
Great. Another question over here.
What can I, as an IT professional, do and a DNS admin to get DNS out there for my domains, and how do I implement it, and where should I start looking for that sort of thing?
We're so glad you asked that question. Maybe Ken and Dan, can you help on this one? And timelines.
Yeah. So there are a lot of tools that are out there to help you do that. I would say initially don't try to overdo it. Okay, in other words, don't try to adopt a policy that the root and top level domains have with rapidly changing signing keys, because I think if you do that, you're opening yourself up to a huge management nightmare of trying to figure out when you need to roll them and all those sorts of things. The keys are pretty strong, and at your level, they're probably strong enough to last a very, very long time without having to change them. Dan might disagree, or you might agree, but there are a lot of tools out there. And I think that there are some better tools that are going to come along. So you have a couple of options. If you've got the time and you've got the resources to use the existing sort of command line tools that are available to you today, then by all means do it. If you don't, then I think that you still want to deploy DNSSEC and you're still set on it, then I think what you need to do is you need to start sort of looking at what managed DNS offerings might be out there. Now, in terms of timelines, so as Rod said, there were, I think, 9 signed top-level domains. Tomorrow there'll be 10. Okay. Then in, pardon? .com will be signed in March. Okay. .NET in November, December timeframe, okay, and .edu the next few days. Okay, so that's sort of the timelines for those top-level domains, and other top-level domains such as .org and others have already begun that implementation process, and in fact are signed today. So it's at the top-level domain, it's happening pretty quickly. There are a lot of tools out there, but those tools need to be improved unless you've got a lot of time on your hands.
We are at the first wave of a revolution in DNSSEC. 18 months ago, the unquestionable reality was deploying DNSSEC was a train wreck. Everyone knew it, everyone was open with it, but we all knew it was going to get better. In those 18 months, when you look around today, you see 3 remarkably mature open source solutions, Open DNSSEC, Power DNSSEC, which I believe is public, and even Bind 9.7 has made a lot of strides in what they call DNSSEC for humans. We're also seeing very nice commercial products from Accelerants, from Secure64, and from Infoblox. The Infoblox solution is great, just commenting is wonderful. And beyond that, the managed solutions out there are fantastic. You know, Affilius, VeriSign, DIN.org, UltraDNS, the amount of things that are out there to make DNSSEC operationally viable is enormous. It's only going to get better. If you've ever heard this stuff is hard, it's getting a lot easier. You asked very specific questions about timelines. Here are the timelines that I see. I see over the course of the next 6 months, it becoming clear that there's a new generation of best practices to develop for how to affordably and effectively deploy DNSSEC. At the end of those 6 months, we'll start seeing the beginning of products and services that depend on your infrastructure having DNSSEC available. After about 9 months of those being available, we'll start seeing the big guys start moving their products over to this. Meaning, over the course of the next year and a third to 2.5 years, we'll really see some interesting stuff happen. Now, you're right, it's not instantaneous, but this train is moving, and nothing's going to stop it.
I just want to build on that very quickly in terms of time frames. As Ken mentioned, the time frames for .NET and .com, for those zones being signed, within 12 months, it looks quite certain that well over half of all the domain names in the world will fall under top-level domains that have been signed under DNSSEC, because the major top-level domains are working on that, and so good progress is being made on that side, which provides an important part of the foundation, as well as the others in terms of the software enhancements. The other thing I want to mention for a second is parties here have been very kind in recognizing ICANN's role in DNSSEC and ITF's role. I also want to recognize the Department of Commerce and VeriSign, who've been partners that we've worked together with side by side on signing the route, and thank them and recognize them. So please give a hand to those parties, if you would, for everything they've done. Thank you.
Man, people give me way too much credit.
And I'd just like to add again from a deployment perspective, you've heard kind of Dan's vision of where this is going to be. If you have a large organization, if you have a small organization, you need to start thinking about it and planning now, because you start gathering your resources, start inventorying your environment. Even if you decided to do it today, it's going to take a little while to do this. So you need to start the planning process now for the benefits that we're going to see in the 9 to 18 month time frame.
Yeah, I'd like to build on something Dan said, and maybe get Whit's perspective on this as well. For the first time, we actually have a pretty seamless signed message system that almost every computer can digest, okay, where the packets are digitally signed. And once this is fully implemented, we tend to think of DNSSEC as only about domain names themselves and not about the rest of the information and the other kinds of things that could be carried. The possibilities, I think, are way beyond just protecting against cache poisoning and things like that. I think it's a message system now that has some inherent security which will allow us to transport other kinds of information in the future, information we haven't even thought of yet, that I think is going to be very interesting. And I think this now opens a possibility because it is so seamless and the trust is so seamless that the user doesn't have to do anything, but it can be built into software to take complete advantage of that. I'd kind of like to get Whit's kind of perspective on that, having seen PKI evolve over the years.
Yeah, well, that sounds right to me. Once you get a working mechanism, that people will then, the way things evolve is people push it to do things that you had never expected it to do before. So yes, I expect this. I'm with you.
I guess I wanted to, following up on that, just to put something out to some of the other folks on the panel. What kinds of products and services do you think will best take advantage of that kind of a trust infrastructure? Because we've talked about it several times in the past, where there are, it opens, Ken said it opens up a new vista around trust and stuff. So what do you think are the first new things that will take advantage of that?
When I receive email from my bank, I would like to know it actually came from my bank. This is a promise we have been making for 15 years, and we're not succeeding. So the number one application I really see us finally, after all these years, getting secure email. I also see federated identity actually working. One of the demos that I'm really excited about is the ability to say, you know what? I have to maintain that machine over there. So, I'm a Dan at remote vendor. I need to log into root@somecustomer.org, and I need it to just work. And would you believe it? With DNSSEC, it actually did. So there's been so much. How many of these federated identity systems have we seen come across our desks and we go ahead and we test them and they work great, and then you actually try to deploy them and they don't scale? Yeah, I'm done with that. I want security systems at scale. And as Whit has basically pointed out very cleanly, we now have the namespace in which this can actually be done.
Great. And thanks, Dan. And Sandy, in response to your question, I'd just say, as an observer here, I want to build off the comments that Jeff Moss made this morning in the opening session. How many people heard Jeff's remarks at the opening session this morning? Okay. Well, as you recall, what Jeff talked about is he said, we've been working on security for many years. Black Hat's been meeting for 13 years, but what's really been accomplished? What success has really been scored that's changed the security situation or landscape for corporations, users, governments, other parties? And his comment was, there really hasn't been a lot, but today and now there is one, and that's DNSSEC. That this is a major change and a milestone in security opportunity for the internet. What we see happening and hope to have happen with so many talented people on this stage and elsewhere is a profusion of applications, technologies, and tools that'll leverage this new piece of infrastructure that in some ways is like the GPS system, right? The GPS system got developed for a very narrow, specific set of applications initially, but then became a service that could be leveraged by many different new and unanticipated applications that got developed over time, many of which are now on our cell phones. That wouldn't have been envisioned at all when GPS was developed. So this is a very fundamental new technology that's being introduced, and we'll be excited to see, Sandy, what everyone comes forward with. Any other questions? We have a, yes, sir, please.
Hi. Well, I'm curious what your thoughts are on social engineering threats, cousin domains, IDN spoofing attacks, things like that. Is there an opportunity for DNSSEC to fix those problems, or those things that need to be fixed higher in the application stack?
So this is actually a fascinating question because a lot of people have asked, why can't ICANN do something about like bank-of-america.com? You know, why is this a thing that happens? And the thing is, DNS's strength is that it is a delegated namespace. That once you have a chunk, as long as no one else is using that chunk, you can put whatever you want in there. Making DNS not DNS is not going to work. That is what extended validation is for. That is what certificate authorities are for. And a lot of people think DNSSEC means we aren't going to need the CAs anymore. They're wrong. The certificate authorities are more important now than they've ever been, because they are the third parties that have boots in the ground all over the world to differentiate what is a domain and what is a brand. Brands are a closed namespace. You can't have something that's like McDonald's dash. Like you can do that with domains all day. You can't do that with brands. We see DNSSEC actually bolstering extended validation. There were some brilliant attacks run by Mike Zussman and Alex Soderov against extended validation last year at Black Hat that talked all about the limitations of extended validation. Those limitations are actually completely resolvable as long as DNSSEC can provide the exclusive description that not only is this an extended validation cert, but this is the only certificate for this domain. That is a fundamental transformation in our ability to deliver secure systems.
Yeah, I wouldn't get a false sense of security in some of these areas, though, because here's an interesting scenario. What if someone did, in fact, register bank-of-america.com and then signed it? They control their keys, right? So they can sign their own zone if they want. You'll get a response that says that it's signed, but would you have actually noticed if it was --of America? And that's where some of these other elements that Dan has talked about are going to become more important, where yes, the answer that you got was digitally signed, but whom digitally signed it, and is it really Bank of America, or is it this other fictitious company? With respect to social engineering, though, there are lots of aspects of social engineering, and I think it's also important to realize, particularly in the DNS system, that wherever human beings are involved, there is a risk of the human beings making a mistake. In other words, someone calling up and saying, I'm a representative of Bank of America and I want to make a change to my domain name, change the name servers, et cetera, or change my keys or what have you. Those things are attempted every day, and there's a lot of work that's being done at ICANN and within the DNS community to try to thwart some of those efforts and make it much more difficult to do that through multi-factor authentication and through other areas. But social engineering is not a new problem. It's one of the oldest hacking techniques out there. But wherever human beings are involved, there is a risk of someone making a mistake, and this can't prevent that, but it can make it certainly much more difficult.
Are we going to be able to still see South Park being streamed over DNS? And what I really mean by that is, what are the performance hits?
What was the question?
The question is, and you actually are the expert in running, managing a large-scale, high-performance name server.
Yeah.
The question is, what will the impact be of DNSSEC on the performance of the DNS?
Well, it's interesting. I mean, some of our colleagues have done some fairly large-scale tests. Comcast, for example, is one of our customers that's done a number of different tests on fairly large-scale infrastructures. And I can tell you that the signatures are large, and the amount of memory taken up to run the DNS in that scenario for large ISPs and tier 1 providers and things like that is non-trivial. So there's a lot of work that they're going to have to do and deploy more servers as well. There'll be increased traffic on the route and the top-level domain servers as well, in terms of the amount of traffic that's coming in, both UDP and probably also TCP traffic as well. I think people are just getting a handle on that, but I have to say, I think that it's like one of those things that, 10 years ago, the amount of computing power that I had in my desktop, I now have in my iPhone, probably even more in my iPhone today, and the capabilities of it. So I think, it's not so much that the march of technology won't catch up to it. I guess that's the best way of saying it. I'm sorry? I'm sorry, I missed the proof of
concept still work was the question.
Here, I'll answer this. So what he's referring to is, my first demos in DNS involved streaming audio and eventually video over DNS, just because it was
just for fun.
It was fun. Yeah. Once upon a time, this stuff was just fun and games, and then it got a little more serious. I will say this. So I haven't done the work that Sandy has in building recursive servers, and clearly the recursive load is increasing in DNSSEC. From an authoritative perspective, it's not just hardware that's gotten ridiculously more efficient. The kernel. So when I did my first talk at Black Hat, I'm like, man, these kernels are so slow. I'm just going to generate the packets myself. Yeah, so kernels are good now. I ended up writing a very small lib event-based DNSSEC server. So what was it, 60,000 queries per second used to be all that VeriSign used to do? Yeah, so you could do 60,000 queries per second on one server and this is what's significant, it's not like you gotta be a genius to write it, in like a couple hundred lines of code. So we live in a different world of available performance and importantly, than even DNSSEC itself was originally conceived of.
So just to sort of throw out some real metrics from what we've actually seen from what's been deployed thus far, about 50% of the queries to the servers today are asking for an extended response. And those responses are about 4 times larger than they were before. So it's about doubling of the bandwidth itself. We haven't seen a significant increase in the query volume, in other words, the numbers of queries per second that we've seen, but we have seen it go up on the TCP side. And a lot of that has to do with the fact that just depends on how different devices handle fragmentation or those sorts of things. But by and large, with the extensions to the length of the DNS packet, you got to remember that 5 years ago, 512 bytes was it. That was it. And so streaming South Park, you had to jam it into a bunch of small packets. But now we have much larger packets and fragmentation's allowed and those sorts of things, which isn't. Yeah. Now we can go HD. So, but of course the bandwidth's going to go up, and of course the load's going to go up on the servers. Get over it. It is okay, and that's. You just have to face it. DNS load in general, with or without DNSSEC, was going to go up one way or another. Now it's just gone up in a different way. But the other things will still drive load as well, and I think we still have to be prepared for that. And that's what I said earlier in my opening remarks, was that DNS is an interesting protocol. DNSSEC is even more interesting because of the possibility it allows DNS to do other than just serve up an IP address for a domain name.
My question is probably a little weird. I run a closed network lab for testing purposes. In that lab, I had to emulate the roots. This sounds like it would be pretty difficult for me to emulate this in a closed, secured lab where I'm testing malware. Has someone thought of how I could replicate this for malware forensics?
I am kind of, only reason I'm grabbing the mic is because yes, like that's been a quiet little thing that's been in the background. Like, how do we actually support these closed chunks? And you have some issues if you're trying to hijack the namespaces that you don't control. But if you do control the namespaces, you can basically make a stub emulation of those namespaces and then bring them into your own root. If you don't do that, then anything that's a validator does in fact need to be modified to validate against you and not against the real root.
But it's certainly the case. I mean, if you do the stub trick, I mean, all of the servers basically have a way to set up a trust anchor for the thing that is what you're looking for. So that's something that most of the resolvers have.
Anyone else want to pick that one up? Otherwise, there's
There's some people with long-standing questions back there. So
Yeah.
a guy in purple who has given
man
up,
in green.
and a guy in green.
and others. Send the proctor running. Sneaker net.
Just to your left.
I was just wondering, there's been a lot of talk of how the servers work and how the endpoint resolvers work, but what are the implications at the client tier here? And how are these errors going to get propagated up to the users, especially on systems that may not be the latest, greatest patch levels or anything else?
So there are two philosophies. One philosophy is, you know what, you let your recursive server do the work and maybe some information gets back to the client and maybe not. And the other philosophy is end-to-end trust is awesome and anything that is not end-to-end trust doesn't matter. Not to disrespect the former, I'm a fan of the latter approach. The way that we sort of see things moving is the actual certificate verification engines are going to be updated to validate against DNSSEC. So when the client is actually trying to be secure, before it was using the certificate authority system, which worked as best it could. Now it's going to be able to use DNSSEC. And the nice thing about this is this aspect of the API subset has inherent in it handlers for, hey, before it was the certificate is bad. Now it's, hey, the DNSSEC trust chain is bad. So you end up being able to leverage the existing infrastructure. There is some value, I mean, not even some value, there's definitely value in validating when available the non-cryptographic trust information, so IP addresses and whatnot. I mean, this is great for recursors, it stops cache poisoning attacks and so on. But where the meat of the value is in making certificate validation work more reliably.
But you think that's going to happen on the client, right? The validation is going to happen on the client rather than on the recursive servers.
I think the recursive servers still need to do validation so that we get the comprehensive fix for cache poisoning attacks. But, you know, I love Starbucks. I think their coffee is great. I'm not trusting a bit in a DNS reply to tell me, oh, by the way, this is the certificate for your bank.
I mean, another answer, yes, that's absolutely right. But another answer to your question is that for those older systems, the former method that Dan was talking about will still provide value. It just won't provide the last mile of value that he was just describing. And I don't know, I'd be interested in getting other people's idea as to whether they think that former model will get implemented first, followed by the latter model, or whether we'll just go straight to the end-to-end solution sooner rather than later.
I think there's no doubt that the former is going to have to get implemented first, just simply because that's the only path we have at the very moment for a lot of it. The client software that appears in operating systems and becomes the default thing that you use, they're going to get upgraded. They're going to get updated throughout time, and I think that you'll see the browsers will start to look for that DNSSEC response and start to inform you in a different way. But up until now, it wasn't even possible for that stuff to even provide any feedback to you whatsoever, because there was no core mechanism to enable it. Until DNSSEC was implemented on the root, it wasn't even possible to broadly deploy DNSSEC outside of closed labs. It just wasn't possible because without a chain of trust, some people tried, and I think we all have varying degrees of experience with those and how successful that they were. But finally, we've actually started something now that will enable those client applications to have something that they can use. Until they do, I mean, why would you put it into the Internet Explorer if there's no protocol to read yet? And everyone at the time was talking like DNSSEC was still another 5 or 10 years down the road. Remember, DNSSEC's been a protocol, if you will, or an extension to the protocol for a dozen years. And it's just taken that long to roll out.
So just as a note, yeah, we're going to release end-to-end client DNS validation logic in like a couple hours. So this game is on.
With recursive name servers moving towards DNSSEC and that whole model, that still requires the client to trust the recursive server, and the panacea is that the client will actually do end-to-end trust as well. Do you have any feel for what the major vendors are doing, like the Suns, the Apples, the Microsofts of the world, what they're doing in terms of incorporating DNSSEC into the end node operating systems so that the application layers can make use of that?
It's not going to start at the APIs. It's going to start in the end applications and then move into the operating systems. That's just kind of the path of innovation now. So it's going to start with the browsers. It's going to start with the desktop applications. It's going to start with the actual code. Instead of calling into the operating system, calling into LDNS, writing the 8 lines of code it takes to do an end-to-end resolve, and using the trusted value from there. That's kind of the path that I see. And then, assuming this becomes popular, then yeah, we'll see operating system level support somewhere down the line. But the flexibility of the end applications is much higher than the flexibility of the operating system, which are just on much longer timelines.
And I'll just add, there's a number of speakers in the program over the next few days from those firms, and you might want to be asking them when they're up on stage what their plans and their timeframes are, because they're in the position to authoritatively answer those questions.
With V6 on the near horizon, what sort of challenges, considerations do you see for people migrating to that in the next little bit?
The V6, I'll speak to it very briefly, and then Ken can maybe pick up on that. The fundamental infrastructure's in place there. The DNS supports IPv6. Allocations are being made by ANA to the regional internet registries, who are then allocating it to their members and users. So IPv6 is available, and it's really time to see some killer apps and driving adoption, and of course scarcity of IPv4 will help drive adoption as well. And with that, I'll hand it over to Ken.
Actually, IPv6 is one of the few extensions to the internet protocols that actually most of the infrastructure is already there into the operating systems. So I think all of the major operating systems today support IPv6, at least the modern versions of them. The DNS system supports IPv6. In fact, there are root servers and top-level domain servers on IPv6 networks today. I don't know of many registries that don't accept DNS or IPv6 registrations today. So most of that's in place. It's now in the hands of the ISPs to deploy networks that are actually IPv6. And I think that the challenge there are twofold and not completely different than those from DNSSEC. And that is, one, do all of the firewalls, load balancers, et cetera, that are in the path support IPv6, or do you have to keep toggling back and forth between IPv4 and IPv6, which some of the earliest implementations of IPv6 today, where people are implementing IPv6, they do have to sort of translate back and forth inside their network to IPv4, and in some cases tunnel the IPv6 over IPv4. Those things are going to exist, but the great thing about it is that possibility exists that we could even do that, where with DNSSEC, almost none of the prep work had been done at the operating system level, at the router level, at the firewall level for all of this until two and a half, 3 years ago when it looked like DNSSEC was catching momentum. So I think as the ISPs roll it out, I think everyone's going to be ready for it because the IANA can assign IPv6 address blocks today. I mean, you could get one today if you wanted. The DNS system supports it. The operating systems support it. So I think we're actually in better shape with IPv6. It's really just the largest of the large internet service providers that are going to have to start providing it end to end.
With the common net TLDs not being signed yet, are there any benefits that companies that use those domains can realize now by signing their domains? Are there any benefits that they don't get, and are there any additional vulnerabilities?
The benefits that you get are what you're going to get from the root first. So you will not be able to take full advantage of DNSSEC in COM or NET today because those zones are not currently signed, but they are on a roadmap to be signed. And essentially what you're starting to see is that these top-level domains are sort of starting from the smaller ones up to the larger ones, kind of in that order as we roll them out. But by this time next year, you'll be able to take full advantage of all those features in DNSSEC for COM and NET at that level.
Can you repeat with the microphone, please? Thank you.
With everyone opening up their firewalls to larger DNS packets, 4K instead of 512 bytes, and opening up TCP port 53 on their firewalls and such, are you seeing a move towards that being abused more? Like, I know DNS has historically been used for command and control for botnets and stuff. Have you seen any other moves towards abusing that new packet size or making use of DNS, those larger packet sizes for malicious intent?
So one of the entertaining aspects about being in the DNSSEC space is you do hear some arguments brought up a decent amount. The denial of service threat in DNS is real, but I said DNS, not necessarily DNSSEC. Like, bad guys haven't been waiting for all the DNSSEC changes to run huge DNS floods. That's been going on for years. The ability to get a large number of hosts to emit a large amount of cache data is already the status quo. We do need to do a lot of work around DOS. It's a problem that's only going to get worse, but it's not special to DNSSEC. And the changes that DNSSEC are implementing, they change things a little, but we're already in the red zone. We don't need DNSSEC to move us over.
They're just taking a bad problem and making it somewhat worse.
Slightly at best.
Right.
I think you raise a good point, but I don't think it's any different than port 443 or port 80, where people will come up with creative ways of getting Skype out the door or something like that by now allowing port 53. I don't think it's any different than that. I do think, though, that the risk is probably no worse than it would have been before. It's just another port that allows larger packets through it. But I'll tell you, it's not as bad as port 443, for example, because port 443 would allow a very long-standing connection to exist, where even port 53, even with DNSSEC, is not going to allow a long, persistent connection. So it's actually better in that respect than it would be. And by the way, I think you're going to see some firewall manufacturers that are going to start doing some inspection of those larger packets for port 53. It's not going to happen probably in the next release of the software, but it'll be sometime in the next 18 months or so.
Good. Well, if there's not any more questions, we'll actually bring this panel session to a wrap. I want to thank all of you for coming. We thank all of you for helping to move DNSSEC forward and further in implementation. And we thank you for the excellent questions. And a last hand and thank you to all the panelists. Thank you very much.